¿Alguien puede ayudar?
No, está bien, está bien.
Hay un experto que pueda ayudar.
Luego hago así, luego así.
Okay.
So, okay, I will do this in English, unless you
Would you use the mic?
Yeah,
mic.
In the table.
yes. So I'll do this in English, unless you insist, unless you complain. But because this is the language I speak to John in general. So I'll talk about, well, it's a bit less pretentious and a bit without so much content as the previous talks, which really impressed me. But I'll try to talk about my life with John and my way of knowing him and seeing him and understanding him as a big example for my career. So then first looking at on the internet and trying to see who John Beckman is. You start with a senior vice president in the States. You find a basketball player, but he must have died a long time ago. You find an actor, and then you find the astronomer. So, but maybe at some time he will be so famous that you'll be the first on the list. So, okay, now, how did we meet? I said this yesterday in the dinner a bit. I think what happened was I just started my PhD. I went observing in the Canaries, never heard about the Canaries. I mean, I had to look on the map where they were. Going observing for 2 observing runs, which were then split on JKT and INT with 2 weeks in between. And after that, I had a few days in Tenerife because I planned them in such a way that, if possible, I would like to see the big institute there. And I think somewhere on the mountain in La Palma, I met someone who knew you, or met you, or somewhere, and so then you invited me to Tenerife, and I visited the IAC, which was at that moment already in the building now, just the bits of it, of course, very nice. And so this was a start of my astronomical career, 2 months after starting the PhD. By that time, I didn't realize, but you had already spent 22 years in astronomy, so I just started. But you knew Dutch, at least you knew some Dutch from your time that you had spent at ESA in the Netherlands.
Forgotten it now.
No, but still, this is history. Your son has come to Holland to study and so on. 2 years later, I came back for the winter school, and that was a fantastic school, as Pepe said. This was in the hotel Semiramis, where you enter through on the 13th floor, and where you then go down to the sea. This is very impressive. The conference, these kind of conferences for people who have PhD students are really important. They create, in a conference like that, you're able to find colleagues, students and so on that you keep for all your life. This is, for example, what the Vatican School promotes, and I think this should be done. This was 2 weeks. Nowadays they're only 1 week, and I think they lost their purpose.
This was not a winter school, it was something different.
Okay.
That's the difference. It wasn't a winter school.
All right, well...
It happened in the spring. Maybe you didn't, but don't worry.
Well, I mean, I'm getting old,
Everything you said about it is true.
I think I'm getting old and lose certain numbers and so on, but I guess that's not bad. So, okay, how this continued. So, first in 1991 somehow a paper was published, and then Johan will talk about this in a minute, on which we were both co-authored. And in 93, for some reason, I became a support astronomer in La Palma, and decided to live in Tenerife and go to the IAC, so I was here often. And as Alejandro told you, we decided to co-supervise Alejandro Vosdicky's work on populations. Well, that was a nice period there, and it was the height of our collaboration. Sure. So, the first paper, also on the sombrero, and I think this picture is very important. So, what did we work on? So there I use a modern tool, which is the ADS. But first of all, the spirit is always galaxies. What do they look like? And I guess an image shows a lot. So that's the point. And I think that John thinks like me, that you like to take an image, look at the image, and then based on the image, or many images, you try to understand them. Mm-hmm. And so this galaxy is a simple SA galaxy, but if you look more carefully, it has a star-forming ring, it has a very dusty interior, and so on. And here you have M51 and 5194, 5195 that you see together, and also you can, from the color image, you can already see so much about the populations and so on. So we have a staggering 28 papers together. That's not really all refereed, it's half is refereed, but 28 papers is something that means quite a bit. And if you look here, then they start in 91, as I said, and they finish at this moment in 2017. And there can be more in the future, of course. If you look at the topics, this is from ADS, there's a lot on the purple part of extinction and dust in spirals. That was definitely in the 90s was a hot topic. And there's also quite a bit on population synthesis, and there's some other stuff on galaxies. So if I go to the first part on stellar populations, I mean, this is really the work that Vosdekis did and collaborators, and this really resulted in a line that went was very influential in the times. This is the Miles library that we made in 2007. John at that moment had moved on to something else, but basically the root, the start of all this was built with the papers of Vosdekis and with Supervisor Beckman, and not Bachman, sorry, and that led to these very influential models, which are the most used in the world at the moment. On dust, so there's quite a few papers on dust. I mean, I do it in order of citations. The H-alpha survey is maybe not that much dust, but it was done by Phil James. But it's still on the kind of galaxies that have them. And then you start seeing papers on scale lengths and on the amount of dust in galaxies and edge-ons and so on, so all kind of aspects. And that's what we were doing. So one of the papers here is the paper on scale length so we looked at scale length in arms, inside spiral arms and outside spiral arms, because the dust should be close to the star formation. So and the idea was correct. So you see indeed that the open points, which are inside the arms, show a lot more variations of scale length with color than the points than the points outside the arm, where the scale length as a function of wavelength is more or less the same, indicating that there is not much extinction. So this was an original idea, and the original comes back with John all the time. Another one is here. So I go, sorry, it was the wrong button. So then there was this paper of me on the amount of dust in the outer parts, because there was a lot of rumors there about that outer parts of galaxies were galaxies were optically thick, so you really couldn't look through galaxies and so on. And this was an answer of myself with John, Edwin Valentine, to look for objects and look for the extinction law test, to look for objects as a function of inclination. And if the color then changes, then if the color then changes, then there must be a lot of dust. If the color doesn't change, there is not. And you see an effect from the middle to the outer parts. So, and then of course this paper, maybe Johan wants to say more about it, but it's totally obvious that if you look at a galaxy from one side, it's the dust absorbs all the light of the bulge, for example. And so by just very simply comparing both sides, you get the amount of dust, and if you do it in different bands, you can get the extinction law. Very simple. There's more sides on it, of course. And then this one is a last one that was done when all these postdocs were here. Michael Polen, who used to be a postdoc here of me in Groningen, and then later came to the ISC. Peter Irwin, who is still in Max Planck in Munich, and I think also Alistair Graham at that time. So there was lots of powerful postdocs here working on this. And someone else will talk about the influence about these different types of bends in disks.
Well,
Yeah.
maybe.
Well, I mean, what you can say is, of course.
This meeting, but
Well, I mean, what is this here? You see 3 types of disk, and actually they're quite important. So the second one is usually the one that is created by bars. So you see that the bar stops in the middle at more or less here. So then the slope changes, and this is a very nice sign of a bar in a galaxy. And in the outer parts there's more kinks and so on, but we not at that time this wasn't the case. And the second one is the up band. This type 3 is usually something to do with interactions, and you also see another galaxy sitting on this. Well, it's a very simple story. Maybe you have more to say, but I'd like to leave it at this moment. So there's a group of. Then the third group was bars and galaxies in general, and that well, it led to an ITP. So it led to this project bars, barred and ringed galaxy spirals. And we did a lot of work actually in there, but somehow the papers missed. But I'm not sure that is so important, because there was the collaboration and there's all the ideas that came and so on. I mean, papers are not all the time everything that you need. And then there was this conference. So I think this was more or less the time you retired. but I mean, I don't think that word retire means much. So it was just a conference. I think it's very nice maybe to have another one in 10 years or so. So, and it's impressive also who came, the people that came to that conference. You can look in archive, you can see a number of these papers. I have the book at home, but I mean, when I made this talk, I wasn't at home.
Yeah.
So what are your strengths? So I tried to figure this out from ADS. And you get something like this. So, Beckman's author network. And there is not one peak. I mean, as obvious, there's like 10 peaks. And the number of authors, the author groups that ADS, that the computer tries to make, is not one, but there's many, many, many. And that's, I think, your life. So you collaborate, you work on all kind of, you have lots of ideas. You work on all kind of things with people in a certain period or together. And it leads all to interesting stuff. And quite a few are influential.
Yeah.
And that's really interesting, that is to see this.
I'm happy to say that even though I don't carry on working necessarily with the same people, I'm lucky that I retain their friendship.
Yes. No, well, that's also important, because there's lots of supervisors that are.
Fortunate.
You can give lots of examples and talk forever.
Yeah.
And then of course this multi-messenger astronomy that you worked on recently. So I don't know, Johan. I could stop here. I'm going to talk a little bit of science in the style of John. This is takes 5 to 10 minutes, or I could stop.
You have time, but
I do have time.
hopefully lunch will wait for us.
Okay, then I do very quickly, because this is a topic to do with the morphology of galaxies, and I think it's really in the style of stuff that you would have liked to do. So this is the Fornax cluster. This is the stuff I've been doing mostly in the last 10 years or so. I went to Fornax, to the southern hemisphere.
Good.
And what is the question? The question is it here? So, do dwarf galaxies have bulges and inner disks? And this question is actually quite important, because what's the structure of them and how do they evolve? And also it has to do with their populations. So, okay, now we analyze this. This is mainly with student Aku van Hola, who now has a position in Finland, and Alan Su, who graduated in 2022. And basically what you see is, if you take all the dwarfs down to magnitude, down to 10 to the 6 solar mass, so really faint, and you then plot them in the color mass diagram. And on the right here, so on the left, the separation is made in the cluster and the nearby Fornax A group, and in the middle, the separation is made in morphologically identified early types and late types, so irregulars and ellipticals. And so there, in those objects, you then try to look for components. And this analysis was done using the famous Finnish software from Heikki Salo, and Sebastian Comeron has been seeing this from nearby. So in a large galaxy, massive galaxy, has all these components, and not necessarily all the time, all at the same time, but it has these components. But dwarfs don't really have very many. It looks like, but it really wasn't investigated in great detail. So they do have a disk. Well, you call it a smooth component. I call it disk, and they have sometimes a nuclear cluster, and they sometimes might have bulges and disks. So here you have the fraction of galaxies with only one component, which means the disk. And the nuclear cluster I don't consider here, but one component means no bulge, no inner disk. And you see that this fraction is 100% for the fainter objects. So up to MR is about -16, and then it goes down to 0. It means that larger galaxies, more massive than 10 to the 9 or so, always have components like inner disk or bulges. And so you see this here, and you see it also in the ones with bulges and bars are indicated with these black circles and they're mostly in the massive galaxies you can see. So it's actually a very strong effect. And if you look at as a comparison for where the nuclear clusters are, they're basically everywhere, and they only disappear at some point because the amount of light is not enough. And so that is interesting to see that these dwarfs just contain one component. Usually it's also fit by an exponential profile or a Sursik profile, so it's really you better call it the disk. So compared with other surveys like S4G and so on, I mean, they have similar results, but they don't go as deep in mass. And the same thing here in some histograms. And so that is the same story. So last one is about the nuclear clusters. You see that objects with nuclear clusters are generally found in the middle of the cluster and not in the outer part. That's quite weird because you could see this as a last burst of star formation, but that's not really in the middle of the cluster, but because there's the old stuff is sitting there. So it's not the last burst, it's something else. And what the nuclear clusters are really is not very clear here. And so I think that's it. We can leave the conclusions more or less what I said. Thank you, John, and I hope many more years. This is the picture of the Arab and the Jew together in Madrid. Thank you.